If you don't know me, I'm Liam Hammett. I do a lot of stuff with PHP, particularly around the Laravel ecosystem. And today I'm going to be talking to you about unconventional PHP. We'll be going over some of the ways that you can use PHP in a way that you probably haven't thought of before. If you're a beginner with PHP, it might be a little bit hard to follow along with some of the things, but I'll try to explain everything as clearly as I can. If you've got any questions, then please ask them in the chat as we go along, and I'll try and clear them up at the end. If you've worked with PHP for any amount of time, you'll probably know that it has a lot of ways that let you interact with PHP source code itself. So PHP gives you ways that you can sort of reflect on classes and values, and you can pass tokens of source code, you can evaluate new source code on the fly, you can serialize objects, and you can do so much more. And I expect a lot of you watching this to sort of have this gut-wrenching reaction to some of the things we're going to go over and think they're horrific. You won't be seeing most of these techniques that we're going to go over in the PHP documentation or in any of those well-known books about design patterns or following solid principles, but that doesn't mean that these tricks can't be useful. And I'm not going to go and tell you to immediately go and use all of these in production code either, but I would kind of want to have this talk to make people aware that there are options to write PHP code in sort of new, interesting ways. We're going to be going over a couple of things where we can bring functionality that's already used in production frameworks like Laravel. We'll be seeing how to make the most out of some of the other technologies that we've already got and how we can add to them. And we're going to have a little look at how we can enable certain functionality that other languages support, but PHP doesn't yet. But before we look at what future features we can find, I kind of want to stop and reflect on the past to quickly talk about what initially prompted me to give this talk, so that we can see how techniques like the ones we're going to go over today have been useful in the past and therefore why they're still worth discussing. So a few months ago, I was trying to find some documentation on php.net, and I came across this page about type hinting, and the page was pretty empty. So the user contributed comments sort of jumped to the top of the page, and I started reading the first one. And it was explaining how to be able to type hint your function arguments with primitive types, like denoting that this argument must be a string or that one must be an integer. And that might not sound very interesting, but what jumped out about this to me was that this comment was from 12 years ago. It was from 2008, and at the time, PHP 5.2 was the latest version. And if you've not used PHP for that long, you might not be aware, but you couldn't actually type in primitive values like this until 7 years later when PHP7 came out in 2015. And so this kind of blew my mind because someone managed to build this highly wanted feature that will run in any PHP environment 7 years before the language itself supported it. And even better than that, it turned out that it was the exact same API that we got in PHP7. So upgrading a project using this technique was completely effortless. So I want to quickly see what the problem is and show you and see how they solved it. So here we've got a simple function that checks if a string is a palindrome. So if it says the same reading backwards as it does forwards. As you can see, this code's being executed against PHP 5.2. And we've type hinted the value as a string, which, like we said, wasn't actually possible in PHP 5.2. So when we try to call the function, we get an error. And the error is a bit confusing. It says argument 1 passed to is palindrome must be an instance of string given. But that's because string wasn't actually a reserved type, so it was expecting us to give it a class with the name string, but we gave it a literal string. So let's now have a look at how this post from 2008 on php.net actually managed to make this work. And here's a slight variant of the code that they wrote to get this working that I just wanted to quickly look at. The main thing that it does is that it sets an error handler. So whenever PHP encounters an error, it will run this function to do some custom logic. So there's a lot of stuff here, but we're just going to go over the important bits. One of the first things that it does is it checks the error message that came up from the error and makes sure it matches a certain pattern. So we're matching it against the pattern that we just saw. So an argument A must be, argument A passed to B must be an instance of C. And so this way we know that we're dealing with the right error. Once it's done that, it goes on to use this debug backtrace function, which is a special utility that PHP provides. And what it will do is return a list of all the functions that were called to get to this point in time, and along with any extra little details like what values were passed into those functions. So now we have that debug backtrace, and it passes it into another thing that will go over and basically iterate over every function that was called until we find the one that triggered the error. And when we do that, we actually also pull out the value of the argument, which we can then use to assert against. So once we've got that, we know what type we're wanting to hint against, we know what the value is, and we know that we're dealing with the right error. So all we really have to do is check that. So here we've got a little mapping that gets called. So in our is palindrome example, we type inted the value as a string, which maps to the isString function, which is something that PHP already provides. So if we've passed it through a string and we're checking the isString function, it will sort of return true, and returning true from an error handler sort of tells PHP, okay, pretend like this error didn't happen and just continue running the code like you were before. And if none of those conditions were met, maybe it wasn't actually string that we were passing through, or maybe when dealing with a different error, then it'll return false, and that tells PHP stop and continue executing the code like you were before. That's kind of it. Now, the only change we need to make to the initial code that we had was to make sure that we include this error handler, and it suddenly works. And with only like a few lines of code that now we understand, we could use this nice syntax to check if a value is a string, all the way back in PHP 5.2. Now, that might not seem particularly relevant today. Hopefully everyone watching is running recent versions of PHP already. But the idea of that is to show you that PHP isn't just a closed box of documented things that you're allowed to do. If you think a bit more abstractly, you could make it do a lot more. And here we managed to introduce a clean native feeling syntax into PHP 7 years before PHP got it itself. So sort of step back and think, what will PHP like? What will PHP be like 7 years from now in 2027? What features from then would you like to have? But you don't have to wait nearly a decade for it. And that's basically the premise of this talk today. So the first one I want to talk about is typed variables. And this is something that Nikita Popov, one of the primary maintainers of PHP, talked about when PHP 7.4 was first released. And that's because it's only now possible with the new features it introduced. But when you heard about PHP 7.4 coming out, you probably didn't hear about typed variables. And that's because it's not really a first-party feature. It's something that we can kind of make work. So let's say we have a variable I, but we can't be sure what type it is. It might start off as an integer, but it can be reassigned to something else later on. So in a nutshell, typed variables is a way to prevent that and make sure that the variable doesn't change its type later on in the program. And we might start protecting something like this by wrapping it in a function. And this way we can ensure that the initial value is always an integer, but it still doesn't check for it being reassigned later. So unless we call this function every single time we change the variable, it won't get type checked. So see how we can make this function actually do what we want it to. We've rewrote a little bit here so that it basically does the same thing. We're creating a class with a type property called prop. We're assigning the integer to that property, and then we're returning the property. And on its own, this has no different effect than the previous code, and that's because we're just returning the value of the property at the time. But the interesting thing is if we tried to change the value of that property, PHP would throw a type error because it can only be an integer and it can't be a string. So we need to do a little bit more to get that working. And the first thing is to add these ampersands to both the assignment and the function. And that will tell PHP that instead of returning the real value of the property, we just want to return a reference to it. We want to return a reference to the property on that class. And that's important because it means that now when we reassign it, it's treating it as if it should be reassigning the property on the class too, and it will validate the type as we do that. And that wouldn't happen with regular argument and return type hints and functions unless you passed it through to the function every time. So there's only one last little caveat that we have to worry about here, which is PHP's garbage collection. And this is what PHP does to try and free up memory by getting rid of things that we no longer need. In this function, when we return, PHP thinks that we no longer need the object at this point, and we only need the property value. So it'll completely get rid of the object, meaning that we're not dealing with the typed property anymore. And somehow we need to keep the object alive so that it is a real object and property, even after we return from the function. And one kind of simple way to do this is just by adding it to a superglobal variable. And that means that the object will always be referenced in memory, even after the function's returned its value. And this means that PHP doesn't destruct the object, so we're returning a real reference to that property, which still has the type against it. And magically, now that works. Now when we reassign the variable to a string later on, PHP will try assigning it to the type property, and it will throw that type error. And just to show this works, we can still reassign the variable to something else later on as many times as we want, but as soon as it becomes a different type, it'll throw an error that you can handle. And this approach may seem a little hacky, but it now lets us protect variable types in our code in a way that we just previously couldn't in PHP. And this can have huge benefits for long procedural code. Just gonna have a sip of water. So the next trick we're going to go over is called function piping, which is something else that can help with a lot of procedural code problems. What do I mean by piping? You might be familiar with the term if you've used a language like Bash, where it's a commonly used feature, but simply put, it means taking one value and piping it into another function. So to start off, let's see what problem this solves. We've probably all seen code like this at one point in our careers. It's a single line that does a mishmash of things, and it's really hard to read. Here, it doesn't even fit on the screen, so let's split it out to make it easier to see what's going on. So essentially, this code is just getting the event ID from the given URL, but it's so hard to read and understand that. What I hate about this the most is that it just doesn't read very naturally. You got to start off in the middle to figure out what the initial value is, and then use that in the context to read a bit further out to see what that does. And then again and again, so you get the whole context of what the final value is. So we could rewrite that code into something like this, which gives us the advantage that now we can see what the initial value is, and we can read it from top to bottom until we get the final value. But I think this still isn't very nice. It's better, but it's not clear. And you probably don't want to have to spend time coming up with a name for every step along the way. After all, naming is one of the hardest things in programming. So in comes the pipe operator RFC, which was proposed by Sarah Goldman a few years ago. The idea of this RFC was to introduce a new syntax to help make code like this easier to read. And so this is what the new syntax would help make our same code look like. And I think this is a lot cleaner personally, and you can read it from top to bottom without having to worry about the intermediary steps. It introduced this new $$ symbol, and that represents the last value from the function, so that you can sort of decide which position in the function argument you want to pass it to. But unfortunately, this RFC didn't pass, so this code doesn't work for now. However, with a bit of effort, we can actually get this very similar syntax working ourselves today in PHP. It's so similar, I don't know if you even were able to spot what the difference is. So just like before, we want to pipe a value through some functions and get the result. So how do we make that work? Well, we started off with the pipe function where we passed in the initial value. So we'll have a pipe function, and this is going to return another object. The object isn't very special to start off. It takes in the value and saves it as a property that we can reuse later on. But the real magic happens inside this magic call function. And this is a special function that PHP provides that makes things behave in a bit of a special way. Essentially, whenever a method on this object is called, and that method doesn't exist on this class, this __ call function is going to be executed instead. And that lets us do our own custom logic instead of PHP just throwing an error to say this method doesn't exist. So firstly, it checks if any of the arguments passed to the function match that special $$ syntax. And if so, then we replace that $$ with the real value that we got. Then it moves on to this call user func expression. And this basically passes through the method name that we got and executes a real PHP function with that. So for example, when we try to call arrow pass URL, then that would come through here and PHP would execute the real core pass URL function with the arguments that we gave it. And then the final thing the magic call method does is it returns the new value, but again in another pipe. And that means that we can chain as many of these call methods off of it as we want. But when we do want to stop that chain, we have this get method where we can just return the real value and stop the piping. So cool, now we know exactly how this code works, and it's only really a few lines long behind the scenes. The pipe function returns an object so that we can call methods off of it. When we call methods, it just so happens that we're using real PHP function names, but they're going through our custom call function. And when we want to stop the chain and get the real value, we can just use the get function. Now, there are obviously some downsides to an approach like this, one of which is that because it's treating them as class methods instead of functions, you could lose IDE support. It wouldn't know how to tell you what the arguments for these methods are because the methods don't really exist. However, this might be an approach that can help you clear up lots of ugly, long procedural code that you have around, like this example. The next trick that I want to go over is static constructors. And these are a concept that a lot of different object-oriented languages have, but unfortunately PHP doesn't really have first-party support for them. So if you're not familiar with the concept, a static constructor is just a function that you can add to a class, and that can be used to initialize any static properties or to perform any actions that only need to be done once for that class. Let's start off and just have a little look at what problems static constructors could help solve. Here we've got a simple class that can get us a list of countries by reading them from a JSON file. It's pretty straightforward, but it has one problem. Every time we want to get the list of countries, it's going to read and decode that JSON, which can be a pretty slow operation, especially if we do it a lot. So instead, we might use a technique called memoization so that we only read the file once. Now with this updated code, it'll only read the file once and it will save the results to the property. And that means that we can call this function as many times as we want and it will have the same result without opening that file again and again. And this approach forces us to go through a getter instead of accessing the property directly because we don't know if the property actually has values. This is a pretty common pattern in PHP, but sometimes we might actually want to interact with the property. So let's take a look at what this might look like if we do it with static constructors. But just before we do that, let's understand exactly what a static constructor is and what rules it needs to follow. So a static constructor is a static function that belongs to a class, and it should take no parameters because you should never really be calling it manually in your application. It should only be called once. We don't want to have to call it several times over. It should be executed before any instances of the class are created, before any static properties are referenced, and before any other static methods are called. So really, it's just a simple function with nothing special about it. All we need to do is make sure that it gets called once before any of the things in the class gets used. So let's set one up here. We've got a function called __ construct static. And this is just to follow the naming convention of PHP's regular magic methods, but there's nothing really magic about this one yet. It just loads the same file into the property just like we did before. So how do we make sure this function actually gets called before we try and access any values or do anything with it? It must be hard to build something that meets all those rules, right? Well, all we really have to do is call it in the same file that the class is defined, and that's kind of it. This means that as soon as we try to reference the countries class somewhere, this file will get autoloaded, which means it'll first define the class, and then it'll execute this function immediately before you can do anything with it. And this is such a simple and straightforward pattern, but it can give you a whole new way to hook into classes and do some kind of logic of your own. And it's not just limited to initializing properties either. You can do whatever you want in this function. So let's take this example of a controller in a Laravel application. The gist of a controller is that you hit a specific URL in your application, and it'll figure out what controller needs to be used for that URL. And then it might return something like an HTML page or an API response. But we don't really care about what the controller does in this case. But how do we know what URL should map to this controller? Typically in Laravel and in most other frameworks, you will have your routes defined somewhere in a file or an array that sort of maps the URL to the controller that it should use. And this can be kind of nice because it gives you one file that you can use to figure out where any request hitting your application starts off. But we could also use static constructors for this. So by defining the route in a static constructor instead, now this route definition is part of the class. It sort of belongs to it. It's all in one file and grouped together. So you don't have to figure out how different parts of the application come together and where those bits belong. And this is just one example of how we might use it, but there are plenty more possibilities that different applications might be able to make use of. But remembering to call this construct static function at the end can be a bit of a hassle though. So what if we could make it so we don't need to put that in every file? In come custom autoloaders, and this is hands down one of my favorite ways to make PHP do interesting things. If you're not familiar with what an autoloader is, I'm going to quickly recap. If you try to use a class in PHP, it might not be aware of what that class is because it's not loaded those files in yet, so it'll throw an error. So PHP provides this handy SPL autoload register function, and that lets you hook into this event so that when PHP doesn't know what a class is, you can do some custom logic to try and load that class in. Here we've got the simplest possible autoloader where if we try to load a user class, it'll try and load the user.php file, which should define what that class is. Autoloading can get quite complicated though. If you're loading things from lots of different directories and using namespaces, maybe including third-party packages, the autoloading code would be an awful lot more complicated than this. So the PHP community built a tool to do this for us. And odds are, if you've only been writing PHP within the last 7 or 8 years, you've only ever used Composer to do this stuff for you. And you might not have even been aware that you could write your own custom autoloaders. And Composer in its autoloader is great. So when I talk about custom autoloaders, I don't mean that we should replace it with something else. Instead, what I mean is that you can have more than one autoloader active at a time. So you can do extra stuff on top of what Composer does, or even before Composer's done its own work. And autoloaders are typically meant to load files automatically. It's kind of in the name, but they don't really have to do that. They can do whatever you want. So let's write one that will automatically call our construct static function for us. So here we're requiring Composer's own autoloader. Then we define our own custom one that will run after Composer's done. Since Composer already autoloaded the file at this point, we can just check that the class already exists and has been autoloaded. But we want to make sure that we pass through the autoload false flag so that we don't accidentally get into a recursive loop and try to autoload a class that we already know doesn't exist. And then if that happens, we can just check if the loaded class has a construct static method on it. And if it does, we can just call it. Now we don't need to include that line at the end of all our classes that use a static constructor. And I want to add a bit of a disclaimer that it's not actually quite this simple to add an autoloader into the chain to run after Composer. There's actually a little bit more logic you've got to do to hook into when Composer has autoloaded a file. But it's absolutely possible, and I can share a link to a plugin that does that already if someone wants that after the talk. But the theory is basically exactly the same as this example shows. So keeping on theme with static constructors, I want to quickly look at how we can use them to enrich our applications with a new feature of PHP 8, and that is attributes, particularly class attributes. So let's go back to this example of a controller, and remember that it needs a route defined somewhere that maps the URL back to the controller. Instead of using a static constructor like we did before, let's take another approach to it and see how this might be looking if we use an attribute. So here we've got exactly the same control as before, but with one notable difference. Now we're defining a custom attribute on the class, and that defines what the URL should be. If you're not familiar with attributes, they're essentially meant to be a replacement for most doc block comments. But because they're not just comments, they're actually a first-party feature in PHP8, and that means that they can get a lot more powerful. They can actually map to a real class, and that class can contain logic. So let's look at what that class might look like. It's a pretty straightforward class to start off. All it's doing is accepting the method and the root that we gave it, and it's saving those as properties for us to use later. But the thing that stands out here is that there's actually an attribute called attribute defined on the class, which turns this root class into an attribute. So let's see how we can make use of this new one that we've defined. Again, we've got an autoloader function, and this will trigger whenever we reference the class. So in this case, we care about when the controller is being referenced somewhere. So using the reflection class object, we can actually inspect what the controller is and get some information about it, such as what attributes it's got. And from then on, we can iterate over all of the attributes that it's got and find when we have the root attribute that we defined. And when we have that, we can just call this attribute new instance method, and this will create a new instance of that root class for us. And interestingly, this will actually have it with the parameters that we gave it when we added the attribute to the top of our controller. So now that we're loading the custom attribute and it has the parameters we want to use, let's make it do something. We're going to add a new register method to the root class, and this will do all the work that we want, really. This new function is going to accept the controller's class name, and then we're going to use it to register a root, exactly like we did before in the static constructor. And now in our autoloader, all we have to do is call that register method and give it the controller's name that we're loading, and we're done. So with just a few lines of code in an autoloader and making a custom attribute, we've kind of introduced a whole new way that you can set up routing for your application that might appeal to you. Your root and the controller can be kept in the same file. And again, this isn't the only thing that attributes could be used for. You could do whatever logic makes sense for your application or class. You might use this approach to apply a middleware to a controller, and an ORM like Doctrine or Eloquent might use it to define what database columns belong to a model. And I'm sure we'll be seeing many more interesting uses of them as adoption of PHP8 rises as it gets released in a few months. Custom autoloaders can do quite a lot more though, and I think hands down my favorite one is Realtime Classes. And this is a super interesting way to use an autoloader to make some magic happen. And essentially what I mean by a real-time class is that you can just create a new class file kind of on the fly in real time, even before composers try to load it in. And maybe even more interestingly than this, Laravel has this as a first-party feature called real-time facades. And it's got quite a lot of use and adoption over the Laravel community. So to rebuild real-time facades, let's quickly look at what a regular facade is and how it can be useful. So we're going to start off with a pretty basic class to send an email. It lets us set who the email is going to, what the subject line should be, and what the body of the email is. And then when we're done, we've got a method to send it. So when we use this class, we firstly need to make a new instance of it, and then we can call the methods off of that in whatever order we want. So the thing that facades will do is they'll get rid of that step where we need to make a new instance of the class. And it does this by making all of the methods on the class available as if they were also static methods. So we can take this and basically get rid of this first line. The facade class itself might look like this. It's a completely separate class, and it just defines a cool static method. And just like the magic call method before, this is kind of special, and whenever we try to call a static function that doesn't exist on this facade class, it'll call this instead and pass through the parameters that we have. And so this call static method is just doing exactly the same as we did before. It's making a new email object and then calling the same method off of that instance. So it's pretty simple. really. And when we try to use it, we get this new interface where we don't have to create an instance of the email class. We can just call any of those methods as if they were static to begin with, and then chain things off of that. And Laravel's own facades does a bit of extra magic behind the scenes. So it does stuff to automatically do dependency injection and to make the facade classes mockable so that they're easy to test. But the simplified version is good enough for our use case. We don't really want to have to create a new facade class every single time we want to use this functionality though. So how can an autoloader help? So again, the SPL autoloader register function actually has a couple of extra parameters that we can give it. And notably, it gives us the option to prepend our autoload function to the start of the autoloading stack. So if we set that to true, normally that would mean that our own autoload function would get called before Composer's done its stuff. So we can override the default behavior to find a class. And by the way, this prepend colon syntax is actually valid in PHP8 with named arguments. So what if we want to use this to write a facade class on the fly in real time? We're going to add a bit of logic to our autoload function, and we're going to have a convention here so that if we try to load any class whose namespace starts with facades, we're going to assume it's a real-time facade and run our custom logic. We're also going to make a new facades directory to put these files in at this given path. And we're going to make sure to hash the class name to SHA1 just to deal with any special characters that might be in it. So now that we know what path we're going to put the file in, the first thing we can do is check if it already exists. If it does, we can just load it and return true to stop trying to autoload. But if it doesn't exist, we still need to make it. So the first thing we'll do is make sure that the facades directory exists, and then we'll touch the file path just to create an empty file. And now we need to populate that file with something. So to prepare for that, we actually need to figure out what the real class name should be by stripping the facades bit from the start of the class name. And that's because we need to actually use it in the file that we're going to write. And after that, to write the actual PHP class to the file, we just need to literally put the code there. We can have the raw code as a completely plain string, and we can have the real class name into that so that the final file has the right class name and can create an instance of the correct class. And then we just send it through the file put contents function into the empty file that we just made. And the last step that we need to do to get that working is require the newly created file to load the class and then return true to stop PHP moving on to Composer's own autoloader. And that's kind of it. Now we've managed to make this autoloader that will generate brand new files on the fly when we demand them. And now that we're done, this is how our final code might look like. So long as we have our autoloader running, then we can prefix our email class's namespace with facades, even if that facade/email namespace doesn't exist yet. And we can call any of the functions off it statically, even if they're not static methods on the real email class. And here we can see what our folder structure might look like after our autoloaders run, where the facades directory contains a file named with the SHA1 hash that we gave it. And now this will work with any class, whatsoever, anywhere in your codebase, so long as we import it from that facades namespace. And so you're probably wondering, isn't this going to slow down our codebase a lot if it's got to create new files all the time? And the answer to that is that it only really has to make the file once, and then it's saved, and it can also load like normal. And it'll only do it for each facade class that you try to use in your own codebase. It won't do it all the time for every single class that you have in your code. And as soon as this file's been created, it can also be sort of loaded into opcache and has full performance benefits, just like any other normal class does. And you don't really have to clutter your Git repository either, because they can be made completely on the fly. You can git ignore that facades directory, and it will just generate them when it needs to that first time. And now again, this is just a small convenience in this example, But you can use this technique to create any classes you might want on the fly, or even add more functionality to the facades here. But now let's take custom autoloaders and real-time classes to the extreme, and let's talk about preprocessing. You're probably familiar with front-end preprocessing with tools like Sass and Less that compile a similar syntax down into plain CSS. And there's also Babel, which lets you take your JavaScript and automatically rewrite it so that that JavaScript works in any browser. But what you might not know is that we can do that exact same thing with PHP on the back end. So there's this tool from Christopher Pitt, and it's called Pre, and I think the tagline speaks for itself. It gives you syntax you like that runs where you need. And essentially, this is a composer package that you can just install into a project, and it makes use of a custom autoloader, and it'll pre-process your source code as it gets loaded, so that you can write PHP with Pre's custom syntax on top, and this package will rewrite it into a file as plain PHP so that it can get run by the PHP interpreter. And it's kind of exactly like how our real-time classes worked before, but this is to a much more extreme level. And Pre's already supported a lot of the things in the past that we've eventually managed to get into the PHP core, like allowing trailing commas in a list of function arguments and being able to use short closures. But it can still do so many things and unlock so many new ways to write code that we just can't do in PHP today. And I've got a quick couple of examples that I want to quickly go over. So one thing that it can let you do is set dynamic values in your properties directly. So if you want the default value of a property to be the result of a function call, or maybe an instance of a new object, you can't normally do that in PHP, but Pre can do it for you. And it lets you do the same thing with function arguments as well. There's also a Pre plugin that allows you to write HTML literally inside your PHP code, just like we can do with React and JavaScript and JSX. We can make operations asynchronous with the async await keywords, just like we used to in JavaScript. Instead of plain arrays, you can create collections that are array-like lists, but have a lot of extra useful functionality built in. You can even defer bits of code to be executed at the end of a block. So, for example, we can open a file and immediately defer that file to be closed. And that doesn't mean it will immediately close the file, but it'll do it at the end of the block, which lets you keep the closing logic close to the open stuff instead of having 50 lines of other unrelated code in between. And like I said before, I don't think we're actually allowed to have a PHP Southwest event without mentioning this for Dave, because he absolutely loves generics, where you can add a type into a class and that type can actually be different depending on how you instantiate the class. And as you can see, these are a lot of features that I'm sure we'd all love to have in PHP today. And tools like Pre actually make it possible to use. But even this is still just sort of scratching the surface. We can still do all of these things in PHP, but just a lot more verbosely than Pre allows us to do. So for something more powerful that we can't do in user land, we can turn to extensions. And a lot of people think that extensions only introduce new classes. They see things like the Redis extension and the DOM document extension, and all they really give you is a new class that you can interact with. But extensions can actually do a lot more to PHP. They can introduce new syntax, new core functionality, and they can just unlock things you've probably never even thought of. The first one I feel obliged to mention is called Swool. And this is an extension that can basically replace PHP FPM in your web server stack. And doing that gives PHP native async await functionality. You can also run code in coroutines. You can manage your PHP processes with it. You can host WebSocket servers with PHP. And even just using it significantly improves the performance of a PHP application out of the box, even if you don't use any of its other features. So if you're serious about writing PHP apps that are more than just a typical web app, I think you should definitely check that out. The next extension I wanted to mention is one by Nikita Popov, and this offers a different way to interact with scalar values like strings and integers, and it lets you treat them like objects. So this extension gives you a new function where you can register a primitive type handler, and you can do this by giving it the type that you want, such as a string, and pointing it at a class where you want that class to be the object that gets dealt with that string. So now if we have an instance of a string, we can call these methods directly off of it as if they were an object to begin with. And I think this is a super interesting idea personally, because you can essentially use this to define your own way to interact with PHP completely. Maybe you don't like the naming inconsistencies in some of PHP's core functions. I know I don't. And maybe you can't remember if needles or haystacks come first. So you can actually use this to define your own version here without having to affect how PHP's functions currently work, and without breaking any backwards compatibility. The last extension I want to mention is by another PHP core contributor, Sarah Goldman, and it's called operator overloading. But what is it? PHP has a wide range of operators that you can use to compare two values to one another, or to add them together, or to concatenate strings, or so on. But typically we only really think about using these with the primitive types like integers and strings. But operator overloading is a feature in a lot of other object-oriented languages that actually lets you run custom logic when you use an operator on one of your own classes, which can actually make it feel a lot more natural to use. And you might not be aware, but PHP already does this internally in a few of its own classes. For example, if you want to compare two datetime objects together, PHP will realize that if you're using the greater than or less than operators, you probably want to know if one date came before or after the other. And this makes it really easy to write and read this code. So the operator overloading extension brings this kind of functionality to our own classes in PHP. So we'll take this example quickly, where it might come in handy. We have a class that represents how much money something is, but it can support multiple different currencies. So if we try to add two money objects together, it would just throw an error normally in PHP. But with this extension enabled, it'll actually call this magic add method. And that lets us do what we want to figure out how to add the values together. So for the example of money, we might want to convert the value from one currency into another, and that lets us add the two values together. But the thing about operator overloading is it's not just limited to numeric values either. You could do whatever logic you want here, so long as it makes sense. You might use the addition operator to combine two collections into one, or maybe you want to replicate Bash's double angle bracket syntax so that you can pipe a string into a file object. And there are a couple of extensions that we can use today, but what other opportunities can we look forward to in the future? PHP8 is just around the corner. It's being released in November 2020, and there's already betas available to use. And it brings a lot of nice new features, but it also brings a couple that we can use in these unconventional ways. The first one to mention is weak maps and weak references. And these let us reference objects without interfering with garbage collection. And this brings forward a great way that we can share objects around multiple parts of a code base, but without keeping them in memory and sacrificing performance if they're not needed. And this just isn't something that we could reliably do before, so we had to resort to other patterns. Another one that we've already explored is attributes. We've explored one use case, but there's plenty more out there. Attributes are present in Java, in JavaScript, in Python, and in so many other languages, and they've already got a lot of different uses across all of those, and now we can bring them to PHP. And like I said before, docblocks did some of the work that attributes could, but now attributes can do so much more because they can have real code attached to them, and they can even go in more places than docblocks could. And that's kind of all I have for you today. Hopefully it's made you think a bit about how powerful PHP can be as a language, and how you might be able to get some future-like syntax and tools that can help you improve your own applications. And I want to clarify that I'm completely aware that everything we've covered here is a little bit weird. And if you're looking at it for the first time, or you've got a team member looking at you implementing this for the first time, it might not be obvious what they're doing. So these techniques may not be suitable for every scenario. And even if you don't use these techniques directly, hopefully in the process, you've learned a bit about autoloaders, magic methods, references, and some other things that PHP provides that you can work into your own applications, maybe in a more conventional way. Yeah, that's it. Feel free to follow me on Twitter or check out my site where I occasionally talk about doing wacky stuff with PHP. There's a link to the slides at the bottom there, but I'll make sure to tweet out a link to them later too. If you've got any feedback for either myself or Naomi, please leave it on Joined In. And thanks to PHP Southwest for having me.
Wow, thank you very much for that. That was really interesting. That was incredible. I've got so many questions. But if anyone else has got questions, please can you add them to the Q&A. I had one question. I think I was just probably missing something. In your root example, when would the roots get auto-loaded?
So that is the one thing that I didn't actually mention.
Right.
What was it? If I can find it again.
You have to work out what all the, yeah, I couldn't really work that one out.
So which one was it? I guess in either of the examples with the attributes or the static autoloader, you have to somehow load that class in first. And loading a class is actually kind of an inexpensive thing you can do in PHP. So you can iterate over a directory and just load everything in it.
I see. So if you had a convention, all your controllers in one place, you just iterate through all of them to get them all.
Yeah.
Okay. Cool. Thank you. Right. Question from Dan. Why do you think a precompile step is so standard in JavaScript world, but so rare in PHP? Is there anything we can do to make precompiling more common?
I think it was needed in JavaScript for a long time because you don't know what environment your code is going to run in. If it's going to run in an old version of JavaScript from 20 years ago in like IE4 that someone's using somewhere, because someone probably is. But in PHP, we've got control of the server, so we always know what it's going to run in. So if we want to use new syntax in PHP, we just upgrade PHP. But we can't really do that with the user's browser. So that's why I think it's common in JavaScript, but not so well known in server-side languages.
Cool, thank you. Dan, if you want to come back on anything, then just add an extra message in there. David Lum asks, what tool did you use for line highlighting in the presentation? It was really good.
I've got these on slides.com, which offers it, but there's an open source thing called Reveal.js, which basically lets you make slideshows like this, and that's one of the features of the code blocks.
Oh wow, brilliant.
I was a bit afraid of doing live coding for all this stuff, so I figured this is a pretty good alternative to point at what code I'm talking about.
Yeah, no, I like it. I like it. There was can you tweet that out, please? The tool you use, or put it in the
yeah, sure,
the channel. Yeah, thanks. I mean, no one else has got any questions. Oh no, there's one more. Dan asks, is there anything we can do to make pre-compiling more common?
I think it's a tough one because pre-compiling is a really awkward thing, because if you've got files that don't have normal PHP syntax like that, then suddenly tools like SUM or PHPCSFixer will see it and they'll go, that's an invalid PHP file. I can't do anything with that. So there's kind of this trade-off where if you have non-standard PHP files with pre-processing, you can't necessarily use all the tooling that PHP currently has available. So there's actually a project by Christopher Pitt, who made Pre, and Nuno Maduro, and they're trying to sort of make Pre a new thing with like lots of standard pre-processing rules. And I think they've built a VS Code extension or something to be able to sort of get syntax highlighting working in it properly. And I think they're working on the integrations for all those other things with their standard syntax. So it's a bit of a tough one because you've got to also work with all the tooling that's in the ecosystem to be able to support pre-processed code.
Yeah. Yeah, because haven't they got something like Pre was released ages ago, wasn't it? And then they're working on something which,
yeah,
they mentioned the name, but they haven't put it live yet. Sorry, PHP?
PHP Plus or something.
Oh, that was it. Yes. Yeah. But that's still unreleased at the moment.
Yeah, I think it's still unreleased, but they are sort of working on it behind the scenes.
Yeah. Yeah.
So hopefully we'll see it sometime, maybe this year.
Brilliant. So I've got one other question about the real-time classes. Could you use that to kind of get AOP type functionality? So specifically what I'd be interested in would be like a ATAT transaction or whatever the attribute format will be. But so you could do ATAT, so in Java where you can do transaction boundaries. So you can just say, when you enter this method, start a transaction boundary, and when you leave that method, finish the transaction. So it's just, you would have to do something extra. So when the class is loaded, you'd have to look at it and go, are there any transaction attributes on it? And if there is, I'm going to modify that class.
You probably could if you paired it with some kind of pre-compiling step, but I don't know how you would do that in like for an individual method. Obviously, like the example that I gave with class attributes is because you can autoload a class, but you can't really hook into when a function is being called unless you literally put something in that function.
Well, so you could just, I suppose, do similar to what, Doctrine have it for your compile stage, don't they? Where you don't use the actual entity, you use something that extends that entity and does something different. So I could know what I need to do to the class to modify it.
Yeah.
So you say I want to auto load, I don't know, person repository, but what it actually does is it auto loads, my modified person repository, and as part of that, there is, before you call whatever method, it calls another method. So you're rewriting the code on the fly.
Yeah, exactly. And I think there are lots of tools out there that do this already.
Right.
The notable one is Aspect Mock for code exception. And that basically puts in a couple of hooks at the start and the end of every function that you call in a test so that it can sort of do its own checks.
Oh,
so
I'm thinking on production code.
Already a possible thing.
Yeah. Okay, cool. Has anyone else got any more questions? No, right. Well, thank you very much.